climate system is driven by two things: the way energy from the sun moves in and out of the atmosphere, and the way heat moves around the atmosphere and the oceans. Energy from the sun is the main driver for our climate system. When the energy from the sun reaches the atmosphere, some is absorbed and some is reflected, mainly from clouds. Most of the remaining energy heats the Earth's surface, although again a tiny fraction is reflected. The Earth's surface then loses its heat again through rising air currents, radiation, and the evaporation of water. Some of this heat passes straight through the atmosphere and back to space, but some is absorbed by greenhouse gases like carbon dioxide, water vapour, methane, and ozone. Most of the air, nitrogen and oxygen, doesn't do this. The atmosphere re-emits the absorbed heat. Some escapes to space, but some heats the Earth's surface again. Eventually, all the heat escapes into space, but not before the temperature of the Earth has been raised enough to allow us to survive. If the greenhouse gases didn't absorb and re-emit heat, we wouldn't be able to live on Earth. If nothing else happened in the Earth's climate system, weather and climate wouldn't change across the globe. However, the sun's energy is distributed unevenly across the globe. Because the Earth tilts, the sun's intensity changes at different latitudes and in different seasons. Generally, there is more heat near the equator than there is at the poles. In this example, the variation is shown during the northern hemisphere winter. To balance this inequality, the climate system moves heat from the equator to the poles through the atmosphere and the oceans. In the tropics, near the equator, thunderclouds develop, forcing warm air to rise and then drift towards the poles at high levels. Cooler air flows in the opposite direction at the Earth's surface, setting up cells. Similar cells develop in other areas as you move towards the poles. At the boundaries between these cells, air is either rising from the Earth's surface or falling down towards it. Where the air is rising, you will get low pressure, often with rain or snow. Where it's coming down, you will get high pressure and fine weather. That's how heat is moved around the atmosphere. Now let's see how it moves around the oceans. Changes in sea temperatures and saltiness create ocean currents. For example, the Gulf Stream is one of the strongest currents in the world. Surface water in the North Atlantic is cooled by winds from the Arctic. Cold, dense, salty water sinks and travels towards the equator deep in the ocean. In turn, the Gulf Stream moves warm water from the Gulf of Mexico northeastwards at the surface to replace it. This brings warmth to northwest Europe, making the climate milder than any other place at the same latitude. It is these interactions between the sun's energy and how the atmosphere and the oceans move heat around the Earth which produce different climates in different parts of the world and set up variations in our day-to-day weather. A warming world caused by increases in greenhouse gases could upset the delicate balance of our climate system and have an impact on our longer-term climate.